All right, this lesson right here, like I said earlier, looks very similar to what we just did. You know, with the parallel lines cut by transversal. We're going to talk about some of the same words: alternate interior, alternate exterior, corresponding, consecutive interior, all that good stuff. But we're going to talk about it a little differently. Let me do this. I've asked you this question before. Hopefully, you'll know exactly what to say in this situation. And we'll just go like this. We'll go 1, 2, 3, 4, 5, 6, 7, 8. When I first taught this stuff the other day, I think that's how I numbered the angles. Now, right here, tell me something about angle 1 and angle 5. Angle 1, right here. Angle 5, right there. Not consecutive. They are corresponding angles. So what's true about corresponding angles? They're what? Are they? Very good. That's what I was fishing for, okay? They're only equal to each other. Corresponding angles are only equal when you have two parallel lines cut by transversal. Do I have two parallel lines cut by a transversal? I don't know. That's right. That's the answer. Exactly right. I don't know if they're parallel to each other. Would you agree with that? What if I told you this? Let's say I didn't say anything about the lines being parallel. Okay, you don't know that they are. There's no arrow there, right, to show that they're parallel. But what if I said this? What if I said that angle 1 was equal to angle 5? What if I told you that that was true? That angle 1 would equal angle 5? That's right, exactly right. If I told you that angle 1 and 5 were equal to each other, guess what must be true about these two lines right here? They've got to be parallel, that's right. So it's kind of the same thing as the last lesson, except the question's a little different. This time, they don't tell you that the lines are parallel, and then you got to figure out if 1 and 5 are equal to each other. This time, they tell you that 1 and 5 are equal to each other, and that tells you what? We'll call this line A and B. So if this is true, then what must be true? Give me the lines. Give me the actual lines. That's right. Then line A is parallel to line B. Everybody see that? So if you have two lines, not necessarily parallel lines, but if you have two lines cut by transversal, and if you can show that the corresponding angles are equal to each other, if you know that, if they told that to you, then you could say that those two lines are parallel to each other. Do you see the difference? Yes, not yesterday, but the last time we did this lesson, it said, if the two lines are parallel, then the corresponding angles are equal. So before, I'll write that down, before, all right, which was, when? Did I teach that Friday or Thursday? Or I guess not Friday. We didn't have school Friday. Probably taught it Thursday, didn't I? Did I teach that Thursday? So anyway, before we said, if you have parallel lines, then what? The corresponding angles were equal. Agreed? Okay, now, what are we saying? We're saying if the corresponding angles are equal, see the difference? If the corresponding angles are equal, then what must be true? Then the lines are parallel. Okay, I'll just put then you have parallel lines. Is that right? Just a little shortcut. So if the corresponding angles are equal, which means, I left out a little bit, if two lines are cut by transversal and the corresponding angles are equal to each other, then the lines are parallel. Do you see the difference between the other day and today? Yeah, it's similar, right? Very, very close, but with a little bit of a twist, okay? So that's why they call this proving that the lines are parallel. So if I can show the corresponding angles equal to each other, that must mean these lines are parallel. What else do you think I could show here? Let's get rid of this and this. Yeah. What if I told you Let's add a little splash of color here. What if I told you that angle 3 was equal to angle 6? Now, the lines aren't equal. What are they? They're parallel to each other, okay? Why? Give me a reason. Because they're alternate interior angles. That's right. If you can show that the alternate, and you don't have to show both sets, okay? If you can just show one pair, okay? If you can show that one pair of alternate interior angles are equal to each other, then that must mean those two lines are going to be parallel to each other. See where we're going? All right. So I could write that down here as well. I'm not going to, but just write the same thing, except instead of corresponding angles, what would you write? Alternate interior angles, right? Okay. Give me another one. And you could do the same thing with 4 and 5, couldn't you? Because they're also alternate interior angles. What else could you say? Let's say angle 2 and angle 7. What if I told you that angle 2 was equal to angle 7? I sat there and I measured it. Angle 2 and 7 are equal to each other. Then what could you say about this? Well, then you could say what? They're alternate exterior, but what could you say? If 2 and 7 are equal, then what must be true? Then the lines are parallel. A and B are parallel. Yes?
Oh, the cheerleaders have to go?
Oh, of course you do. It's Monday. Oh, goodness. What do you guys do? Help the little kids or something?
Yeah.
All right.
Cheer.
Well, if we have a test or something at some point, you're just going to have to let them know that you can't leave when if we have a test. But if we're not having a test, I'm okay. All right, everybody with me on that? So let's go through them. If the corresponding angles are equal to each other, then the lines are parallel. If the what? Fill in the blanks. If the alternate interior angles are equal, then what? Lines are parallel. What's the third one? If the what? Good. If the alternate exterior angles are equal, then the lines are parallel. Okay? What's the fourth thing? A little different this time. What if I said that angle 4 plus angle 6 equals 180 degrees? What if I told you that? The lines can't be supplementary. The angles are supplementary. So if angle 4 and 6 are supplementary, then, now you can say it, then the what? Then the lines are parallel. You see it? All the other ones were if two things were equal. Okay, the only thing that was not equal are the consecutive interior angles. So 4 and 6 are consecutive interior angles. So if I put one arc here, could I put one arc here for the 6? No, because if I did, that means they're equal. Is there any way that those two are equal to each other? No way. That's obtuse. That's acute. But if I put two arcs there, that means they're different sizes. Okay. So if angle 4 plus angle 6 equals 180, if they told that to me, right, or if I was to measure it, but if they're going to tell you, if they're supplementary, then these two lines are parallel. And that's what they are going to be asking you to do. When I say they're supplementary, what do? They add up to 180, exactly. Good, you're catching on. Does that make sense? Alrighty. Let's do a quick example of what it's going to look like on a homework and then eventually on a quiz or a test. Seems like we always do those parallel lines like completely horizontal, but they don't have to be horizontal. So let's do one that don't look so horizontal, like that. And let's say we have like that. There's two lines cut by transversal, correct? Are they two parallel lines cut by transversal? We don't know. That's a great answer, because normally people say, no, they're not. Well, I don't know if they are or not, right? I mean, they look like they could be, but I just don't know. So that's a great answer. So here's what they're going to give you. They're going to call this one line A, call this one line B. We'll call this one T. Why do they call it T, do you think? It's a transversal. This angle right here is 6x minus 8 degrees. They're not just putting that 6x minus 8 in any random place. Do you understand what the angle is they're talking about? They stick it in that little corner right there. Everybody see it? So that's the angle that they're talking about right there. All right, so make sure you understand that. And then this is 4x plus 17. Let's put parentheses, 4x plus 17 degrees. The reason they put that in parentheses, because it means it stands for one number, and then you got the degree symbol outside of it like that. We good? All right, so here's what they say. I'm going to write this down. Find the value of x that makes those two lines parallel. That makes lines A and B parallel. Put the little symbol for parallel so I don't have to write the whole thing out. So what are we trying to do? We're trying to find the value for x in order that A and B are going to be parallel to each other. Like, what does that mean? Well, let's take a look at these two angles. What's the relationship between those two angles? They're what? They're corresponding angles. Very good. Okay? So they are corresponding angles. Whether I know that A and B are parallel or not, they are corresponding angles. Okay, if you look at this, see this group of 4 and this group of 4, aren't they in the same spot? Yeah. All right, so they are corresponding angles, which means in order to have those lines parallel, what must be true about those two angles? They must be equal to each other, okay? They're equal in order to make the lines parallel. Does that make sense? It's a subtle difference, but it's definitely a difference. They don't tell you that those lines are parallel to begin with, but they're saying, tell me what x should equal in order to make those two lines parallel, right? So I got to solve for x, so I'm going to set them equal to each other, right? And I'm going to solve for x, and that's the x value that makes those two lines parallel. Is this making any sense at all to you?
Yeah.
Good. All right, so what are we going to do with what am I going to do with this and this?
Add 'em.
Make them equal to each other.
So I thought we added them and then that's for supplementary.
That was only if they're supplementary. That was consecutive interior. Corresponding. Remember, when do we set them equal to each other? When they're corresponding angles, alternate interior angles, or alternate exterior angles. When do we add them up and set them equal to 180? When they're what? When they're consecutive interior angles. Okay, these are not consecutive interior angles. Look, this is on the outside. That's an exterior angle, isn't it? Okay, so when they're corresponding angles, we set them equal to each other. So that's what we're going to do. So I'm going to go 6x minus 8 equals 4x plus 17. It's a little different than that problem that we did before we started class, okay, or started the lesson. So this time, they would be equal to each other in order to make those lines parallel. And now, we just do what we've always done. Get x by itself. So in this situation, I'm going to have to subtract a 4x from both sides if I want to put it on the left. And in the same step, let's get rid of that 8. How do I get rid of a minus 8? I add an 8. What cancels? The 8's cancel, the 4x's cancel. 6x minus 4x is 2x equals, what's that, 25? Divide both sides by 2, and that's your x right there. It's a weird looking answer. You know, everybody's used to an answer coming out to a nice whole number or a nice integer number. This one doesn't quite do that. It's 25 over 2. Do I need to put that into a calculator and get a decimal for it? No. All right. A lot of you guys grew up in elementary school. They always make you do that. Even in middle school, they make you do that. Probably more middle school than anything. But for now, right now, that's a perfect answer right there. That's all you have to do. All right. So that's what x is equal to. I'm looking at the example in the book. They actually do change it to a decimal, but to me, there's no need for it. All right, all that's going to make you do is just give you one more step, and who knows, you might mess it up, all right? You might put it in your calculator wrong or something like that. All right, this is perfectly fine right there. So if x is equal to 25 over 2, I could put it in for this. Let's do that. They don't ask you to do it, but let's do it anyway. Let's find out what those angles actually are, all right? Because they could ask for that, couldn't they? Sure. So let's put it in here. 6 times x. Well, 6 times what? X. What's x? 25 over 2, correct? All right. And then what else? There's your 6x, and then you got to do what? You got to minus 8. See what I'm doing? Just taking x, plugging it back in here just to find what that angle is. Now look, this wasn't so bad, especially with this bottom being 2, because look what happens. That 2 cancels out with this 6 how many times? Right, 2 goes into 6 3 times. And now what do we do? 3 times 25 is 75 minus 8, which is, what's that? 63? Did I do that right? 67. 6, 7. Ah. All right. Yeah, so it would be 67 degrees. Everybody's favorite. So that angle is 67 degrees. Without doing any other math, what would this angle be? Right. So if these two angles were 67 degrees, then those two lines are going to be parallel. Got it? And it doesn't even have to be 67. In this case it is because of the numbers they gave us. But that's how you do it. We good? All right, let me see. For some reason, I did not take notes on this lesson. So let me just see what else we got. All right, I'm not going to do that. Let me see your homework. Give me just a second. All right, let's do this one. Example 3. I'm almost finished, okay? Everybody write this down? This one looks a little different. Kind of the same, kind of different. Okay. Kind of. That's 1. This is 2. It's 5 and 6. Now this can be a little tricky. There's 4. There's no 7 in here, so don't get all excited. This is lines C and D. Tell you what, I'll put arrows on them. I was getting a little lazy. I should put arrows on these lines. And I believe the other is A and B. It is A and B. All right, here we go. So here's what it's going to say. It says, which lines can be proven to be parallel from the given statement? And then it says, state the reason. It says postulate or theorem, okay? These are, remember we talked about a postulate and a theorem. They're all just different rules. State which one that justifies your answer. So it says, what if they tell you, here's what they're going to do. They're going to say for number, we'll just call it number 1, okay? What if they tell you that angle 1 equals angle 2? Then which lines must be parallel if angle 1 is equal to angle 2? Well, I'm going to mark it on my picture. It looks like they're what? Does it look like they're corresponding, alternate interior, alternate exterior, consecutive interior? They definitely look alternate interior. Okay, which two lines, or which one is the transversal with 1 and 2? C, right? So this is the line and this is the line that these are alternate interior angles with. Everybody see that? Well, I would, if it was me, I would put these little arcs. They're not dashes, they're little arcs. So I would put the arc there because it connects. Look, it connects the transversal to this line, and it connects the transversal to this line. Excuse me. So, which two lines, if those are equal, which two lines would be parallel? See that one right there? And this one right there? See, they would be alternate interior angles. So, my answer would be what? Lines A and what? B. Or if you just put A and B, fine with that. Does that make any sense? Let's do another one. 2 and 3. What if they are equal to each other? Angle 2 and 3. Do they have something in common, this 2 and 3? They are. What do they have in common? What line do they have that crosses both? B, right. Everybody see that? So that is in common. So that's your transversal, correct? So if these are alternate exterior angles, are they? Yeah, this is on the outside and this is on the outside. Okay? So they're exterior and they're alternate. See how they're in completely different places? So they're alternate exterior angles. So what lines must be parallel if 2 and 3 were equal to each other? C and D. All right? And that's what you just write. You just write C and D. If 2 and 3 were equal to each other. If they told you that angle 2 is equal to angle 3, then you could say that C and D must be parallel to each other. Yeah, you could say that. It's probably, in fact, it's probably a better way. You could probably say C would be parallel to D. You're right, Cameron. I think that's a better way to write it. Same thing right here. You could write A is parallel to B. It's probably a better way to write it. Okay? And then we got one more and we'll be finished. What about A and B? What if A and B were equal to each other? Or not A and B, I'm sorry. Oh, what if it said 5 and 6 added up to 180? So 5 and 6. Doesn't say they're equal to each other, but they say they add up to 180. They would be supplementary, correct. So if 5 and 6 were supplementary, which line do they have in common? Which line are both of those angles touching? D, this one right here. Everybody see that? So that's your transversal. That's your transversal. What are your two lines? A and B. That's correct. So if 5 plus 6 added up to 180, that must mean that these are consecutive interior angles, and if they are supplementary, then what must be true? The two lines, A and B, must be parallel. Yep, so A and B would be parallel. If I knew that angle 5 plus angle 6 added up to 180, that must mean that A and B have got to be parallel. All right, because again, see how 6 connects to this line right here, 5 connects to this line right here? That's your transversal. So it's the other two must be parallel to each other. Make sense?
Yeah.
I say that all the time, and I probably shouldn't say that, because if it doesn't make sense, you probably wouldn't even say anything. Let's see what your homework is. Your homework is 1 to 22. So it's section 3-2, pages 116, 117, and 1 to 22. Oh, I said 22. All right. Everybody got it? All right, you got 15 minutes left in class. It's a good time to take advantage of it. All right, it is your study time. So let's get working on it, and let's get as much finished as you possibly can. Everybody good?